Hello and welcome to another one of D's ADD videos. Today we're going to be looking at a particular solution to a non-homogeneous differential equation. First, let's go through the steps again. We're going to have to find the characteristic equation to our homogeneous equation, solve for r, check for repeated roots, and this one will not involve a repeated root, however, for example, 2 will, so check out that video if that's what you're interested in. And mimic your particular solution by looking at your f of t and setting up some general numerical coefficients. And then after that, I'm not sure what that was, it came from outside, so like a dinosaur. Oh, there it is again. I guess somebody's trying to rev up an old engine. Okay, so take the derivatives, plug in, simplify, equate the coefficients. So let's look at this example here. We have that, so if we were to look at y double prime plus 9y equals 0, we get r squared plus 9 equals 0, so r squared equals negative 9, r equals plus or minus 3i. If you remember, it's alpha plus beta I, so alpha is 0 and beta is 3. So when we're looking at our homogeneous solution, that's going to be c1 e to the 0t sine of 3t plus c2 e to the 0t cosine of 3t. Again, e to the 0 or any number to the 0 is 1. So this is your homogeneous solution. And we notice that there is no sine or cosine term in your solution f of t function. So when we set up our particular solution, we can just write it in the form of some constant e to the 2t. Okay? Had something in this line here had an e to the 2t, that's when you would say, oh, it's a repeated root, then I got to do something different. Okay? Just check out the next video for that example. So what was the next step? Take the derivatives. We need to take all the way up to the second derivative because of this right here is second prime. So y prime is going to be 2a e to the 2t. Remember, e box derivative is take the derivative of what you got up there times what you had originally. Then double prime is going to be 4a e to the 2t. When you plug in, you're going to get, this is your differential equation. So let's plug in, we get double prime is 4a e to the 2t plus 9, and then that's 9a e to the 2t. Let's erase that. That's an a. And that's going to equal, what was the right hand side? Just e to the 2t. So we have 9 times a is 9a, so 13 when you combine your right terms. A e to the 2t equals e to the 2t. If you want to divide out the e to the 2t's or just equate the coefficients, you're going to get 13a. You won't always be able to divide it out, that's why I'm not hesitating from using that terminology, because there might be some other terms here and you can't do it. In this case you can. Either way, if you just set the coefficients equal to each other, you get that, and a is equal to 113. So then your final solution to this example would be y gen equals y solution plus y particular. So it's going to be c1 e to the, no, actually, c1 sine 3t plus c2 cosine 3t. Oops, got the 3. And then plus 1/13 e to the 2t. And again, you could have some, initial conditions, and prior to plug into here, you could have solved for c1 and c2 way up here, but I didn't give you any in this example. So again, recap. We found the characteristic equation, found it was an imaginary root, alpha was 0, eliminating the e term that would have been there, right? Because e to the 0 is 0, or sorry, e to the 0 is 1. And then you plug in, or we created a particular solution by comparing that to that, and because there was no repeated roots, I could just say some number times e to the 2t. And then derive, plug in, equate the coefficients. Okay? That's basically it. So check out the repeated root example and the superposition example as well. And practice, practice, practice. Thank you and have a nice day.